All right, here we go on 4.101. All right, so hard water is hard because it contains either a combination of probably calcium, magnesium, and iron. There's a few others, but those are the most common, which interfere with the action of soap and leave an insoluble coating on the insides of containers and pipes when heated. Water softeners replace these ions with sodium ions, which makes the water not so good for people with high blood pressure to drink. Evan, will you go shut the door, please? All right.
Yeah, right.
So
Yeah.
it asks you if 1,500 liters of hard water contains 0.02 moles of calcium and 0.0040 molar magnesium. How many moles of sodium are needed to replace these ions? Okay, so there's some math that's going to have to take place here. Now, let's talk about doing the math to work through this. One is if we're going to replace, let's say we're going to replace the calcium. Let's talk about that. How many sodium ions do you think it would take to replace?
Double.
Yeah, why would it take two sodiums to replace one calcium? Yeah, the charge. And if that doesn't immediately make sense to you, think about if you had like calcium chloride as a compound. So if you wanted to replace the calcium with the sodium, you have to put two sodiums in there to balance the charge with the chloride. So if think about it this way, it doesn't help. Do it that way. So two sodiums. And how about the magnesium? Would the magnesium be the same? It would be the same. Yeah, it would be the same. So, okay. So let's do some stoichiometry here and figure this out. So I got 1,500 liters of this water that I'm going to use in my house. And yeah, it's hard water. So in that water, let's do the calcium first. So it says that there's 0.02 moles of calcium per liter of water. And then for every 1 mole of calcium, I'm going to need 2 moles of sodium to go with it. Oh, is that all that? Yeah, that's all it asked me. Yeah, it asked me to go to moles. I'll do the other step later. Okay, so we're going to do 1,500 times 0.02 times 2. 60? That's a lot of moles of sodium there. Okay. Now, is that all of the stuff in the water though?
Got to do magnesium.
Got to do magnesium too. Yeah. So, why did that move? I don't know. Oh my gosh. Okay. Anyways, so we'll repeat the same thing with magnesium. Make sure you get all the zeros in there. Do y'all see I'm taking molarity and turning it into a conversion factor because it's like moles per liter. So you do the number of moles equal to 1 liter and put it in there. All right. So 1 mole of magnesium and 2 moles of sodium ions. Well, no, it's not. Maybe 7.2. Oh, 12. Can I get somebody to confirm that? 12. Okay. Yeah.
This is cool too.
Okay. What should I do with those quantities? Yeah, let's add them together, and that'll give us the total number of moles of sodium. So. All right. And that what is that? 101. Yeah, so that matches what the answer key says, so that's good. Now, they asked us if the sodium added to the water softener in the form of sodium chloride, how many grams of sodium chloride are needed? Okay, can we convert from moles of sodium? Can we convert from moles of sodium to moles of sodium chloride?
Yeah.
Yep. And then can we convert to grams from there? Yeah. So that's the approach we're going to take here. So 1 mole of sodium would make or would come from how many moles of sodium chloride? One. Yeah. And then the molar mass of sodium chloride, it's like 1 mole is 58.5 ish. All right, so basically 72 times 58.5. You could be more precise if you wanted to. I got 4,002. Two significant figures. So approximately, probably closer to 9 pounds, actually. Oh, you can't see that. Sorry. Yeah, so 4,200 grams or 4.2 kilograms or about 8 pounds. Usually they sell this stuff in 40-pound bags. So you can imagine if that was your weekly water use, which is pretty average, like for my house anyways, I think that would be about right for a week. You know, if you had a water softener, you'd be going through about a bag of sodium chloride a month. And again, if you got high blood pressure or something where you have to limit your sodium consumption, then you'd have to not drink the water that's coming out of the tap because it has salt in it to replace the calcium and magnesium and iron ions. Questions about that? Okay. All right, so 4.94 says you choose to investigate some of the solubility guidelines for two ions not listed in table 4.1. The chromate ion and the oxalate ion. You're given 0.1 molar solutions, A, B, C, and D of 4 water-soluble salts. So this one, this one, this one, and this one. They tell you some stuff about the color of the solution, and that's pretty much it. All right, and then they tell you when you mix the solutions, you make the following observations. So wants you to write a net ionic equation for the reaction that occurs in each of the experiments. Identify the precipitate formed, if any, in each of the experiments. Let's have a moment of torture and just. And here are the solutions for 4.94.